Alright guys, welcome back. So we talked in our last video about regressions, and again regressions have a continuous y and a continuous x variable. Alright, so today we're going to go through how to actually run our regression test in SAS Jump, and we're going to use the example of age versus cholesterol level. And we'll say this is bad cholesterol, but I'm not specifying that. So in this example, we're going to assume that we have a biological mechanism that shows that as you age, your bad cholesterol increases. So age is going to be our independent variable, and cholesterol level is our dependent variable. So we know in a regression, we regress our dependent variable on our independent variable. So I'm going to have cholesterol level regressed against age. Okay? So that's what we're going to be doing. Let me get rid of this. Don't save. Get rid of my writing pad. And let's go ahead and start in with our analysis. So as you see here, I have an Excel file where I have age as one variable, and again, which variable is this? This is my independent variable, or my x variable, and I have cholesterol as my dependent variable, or my y variable. Alright, and again, I've saved this, and you know, I told you before that you have to save your files as an XLS file. Well, I've actually saved this as an XLSX, and it's actually opening just fine in Jump, so I think maybe they have fixed that error in this past update. So we'll open our Jump. And I don't know about you, but I always get all these windows that pop up, so I'm going to close those out. Again, we're going to open data table like we've been doing, and we're going to find our data set, historegression. Alright, and I'm going to go ahead and hit import. Okay, so now I have my Jump sheet. Again, what we always want to do is double check that we have the right kind of data in here. So, for example, I know that age is a continuous data type and cholesterol is a continuous data type because I'm running a regression. Both have to be continuous. So I go over here and I see my little blue triangles which represent continuous data. So I know I'm good. Start going on my regression. So with the regression, we're actually not going to use fit model like we used with the ANOVA. We're going to use fit y by x. Alright, so we're going to go to Analyze, fit y by x. Alright, so what's my x factor, my x variable? That's age. And I'm regressing cholesterol, my response variable, against age. So I'll put that in the y response variable window. And I'll push OK. And here's my output. So this is actually kind of pretty, right? Just looking at it, I would say, yeah, the variation in cholesterol is explained by age. But we can't be that quick to say that because we first need to look at our p-value. Because like I said, we have to make sure that our p-value tells us that the slope is different than 0 before we can make any real assumptions. So in order to do that, I go up to this little red arrow and I select Fit Line. Okay, so I have Fit Line and I fit a really nice looking line through my data points. Now in order to determine whether or not my p-value says my slope is different from 0. So in other words, I need to see that my p-value is less than 0.05 in order to accept an alternative hypothesis and say that the variation in cholesterol changes as a function of the variation in age. So I'm going to go down to parameter estimates. And as you can see, Jump uses a t-test to determine whether the slope is different than 0. So we have a t-statistic, which not super important for your reporting of your data, but I just wanted to point it out. So we find the p-value that we're interested in not by looking at the intercept, but by looking at age. So this will not always say age whenever you do your research, because this could be any independent variable that you use. But we always want to look under parameter estimates at the row of data, the row of estimates that is for our independent variable, and in my case it was age. And I see here, whoa, probability is less than 0.0001. So what does that tell me? Well, it tells me that the slope is in fact different from 0. It's not a flat slope. So I know that the variation in cholesterol is explained by variation in age. So that's a good starting off point. We know that our slope isn't 0. So now we want to go look at our R-squared value, because right now all we can say is that increases or decreases in our X variable causes increases or decreases in our Y variable. And we can tell by this slope, it's a positive slope, that increases in our age is going to cause increases in cholesterol. Had it been something like this, it would have been a negative slope. And we would have said increases in age cause decreases in cholesterol. All right, so now we need to look at our equation and also our R-squared value. So equation can be found under linear fit, and you can see that they very nicely put our dependent and independent variables in the equation. So this is the same thing as y equals a plus bx. Y, our dependent variable is cholesterol, equals 180, and that's our intercept, plus 0.9025, our slope, times our independent variable. So this is our equation that we would report in our results. All right, now you go down here to under summary of fit, and you see R-square. Now there's R-square and R-square adjusted. We're just going to focus on the top one, R-square. And we have a value of 0.789, so I'll round that up to 0.79. So what that is telling us is that approximately 79% of the variation in cholesterol is explained by the variation in age. Okay? All right, so now that we have all that information, let me just go back through it really quickly to make sure we know the proper steps we're going through. When we do a regression, the first thing we want to do is go down to parameter estimates, find our independent variable, and look at the p-value, so probability greater than t. So our p-value is less than 0.0001, which tells us that the slope is different from 0. We can then go up to linear fit and get our equation, which gives us our slope, and we know because this is a positive slope, we're going to have a positive slope up here. And this is going to tell us that as age increases, cholesterol levels increase. And we have our R-squared value, which tells us the proportion of variation in cholesterol levels is explained by the variation in age. So what we'll do next is focus on graphing regression, and that'll be in the next video. Thanks.